Hello. So in this video, we're going to be talking about the language of functions, and in particular, how we actually define functions. You've likely sort of seen this before in other math classes, but there's a sort of significant piece that's typically left out. So this will hopefully be a relatively quick video in which we cover sort of all of the aspects of defining a function. So you are likely familiar with one of the two pieces. So functions have two parts to their definition. Now you're likely used to seeing something like y equals x squared or something. And that is one of the parts. But we want to sort of write this or do this in a more sort of, again, precise, rigorous way. And as we mentioned before, and we've covered before, there's this whole idea of domain and range, as well as domain and codomain, right? So a lot of the time you've done range, when in fact you really should be doing codomain, where range is a sub-piece of that. So for functions, two parts. The first part is we're going to define the function's domain and codomain. So we do that by giving the function a name. Commonly we use something like f. We separate it from the domain with a colon, so then we'll have a domain. So we could do f from, let's say, R, the set of all real numbers, remember from the sets video, and then an arrow, and then the codomain. Again, commonly we use R. So this tells me that we're looking at a function. That function is named f. So this is the name. This is the domain. And it's taking things from the domain into the codomain. Okay. Now, the second part is the part you're probably more familiar with. So the second part, this is the sort of definition of the function in terms of its, what you might call its path. The second part is commonly referred to as the rule. And it's basically telling you what that function actually is doing, right? So here, again, I would do f, because I've named my function, right? So f is the function. Then I'm going to put in what we would call a dummy variable for the domain element. So it says, okay, if we apply f to x, what does that do in terms of the thing we put in? Well, it takes whatever value we put in, and let's say squares it, and then adds 1. Okay? So this is what we would call the rule. It says, okay, whenever you take an element of the domain, how do you know where that thing goes? What does f relate that to? Well, it relates it to that thing squared plus 1, right? So if I want to know how f affects, say, 2, the way I would do that, let me switch colors here. So if I want to know sort of where does f take 2? So this is sort of the math language. When we say take 2, what we really mean is what is 2 related to? If I put in 2, what is the output, right? So here, this is the input. And really what I'm asking is, what is the output? But again, right, in words, these things are sort of inherently not precise in some way. So we would like to sort of have notation that sort of makes it exact what I'm asking for, right? I don't want to be sort of wibbly wobbly or sort of get the idea across. I want to be very precise. So when we do that, the way we write this question is we say, okay, I'm trying to input 2. So I take f and I input 2. And the question is, what's the output? What does that equal? So to do that, I would say, okay, it takes the input, right? The input here is 2. So wherever I see an x up here, I'm replacing it with the 2 because that's the input, right? So the rule for f is it takes the input and squares it. So my input is 2, and then it squares that thing, and then it adds 1. But now this is just, right, arithmetic. I can solve this stuff. So 2 squared is 4 plus 1, so that's just 5. right? So in that case, the output then is 5. That's where f takes 2, okay? So this is the language of functions, the way we write functions. Remember, we need both context and rule. So this first thing, this was really the, right, if you remember when we first introduced functions, we said they were a relation, a rule, with context. That's what this first thing is. It tells us what is happening, right? What's the domain? Are they blue cars in a parking lot? Are they numbers? Are they fruits in a particular orchard or something, right? That's what it's telling you, sort of what you're applying it to, and the output, right? So if you're looking at blue cars in a parking lot, are you looking at sort of the output is whose car is it, right? Maybe you're trying to associate like a valet or a ticketer or something, right? You know, if it's, you know, fruits in an orchard, maybe it's the price of the fruit. You know, depending on which fruit you grab, maybe it's, you know, $1 a pound or $5 a pound or whatever. So the output sort of gives you, right, the codomain gives you an idea of what kind of thing are you getting out. Is it money? Is it a person? Is it what, right? So here I'm putting in numbers, I'm getting out numbers, and the rule actually tells you how to associate the input to the output, okay? And that's really all there is to it, okay? So with functions, or language of functions, 2 pieces, context and rule. That's everything, okay? All right, we're good?